Hi guys, we're back again. It's the morning after, the night before, that's how you say. We're back on my poor old venerable surface plate. That's, as I said, looked like it was used by a blacksmith for making our horseshoes. We're doing a survey on this. We've done our preliminary machining to get everything squared up, and now it's important to find out where everything's at. And it's important to sit back and do this little bit of a survey and take your time and get your thoughts together. And don't be rushed by it. And if you're doing this sort of work at work, on a work situation, and it might be a very large job you're working on, it might be a big process line that you've been involved with, you're out doing some survey work on the site. Just to confirm a few things, just spend your time. There is nothing worse, and I've been there before, there is nothing worse than being in the middle of a circle with 20 blokes pointing their finger at you when something's not right, and it is a horrible situation to be in. So do your due diligence, do all your checks, and take your time and be right with it. If you're not happy with what you're seeing, or something doesn't seem right, go back and check and recheck. Don't take it for granted, all right? Spend your time. Yes. Alright, so as I said, we've used our little buttons in the past as our reference lines, and as I did mention that we're going to use this particular bore as our reference point for everything to work to. We've got, you know, as I said, 3 or 4 millimeters of thickness in here on the wall, so I don't want to play around with that too much, so everything can follow on from that bore. So all the faces that are going to be shown will be to that bore. The larger bores will be referenced off this bore as well, so if they come up and down a little bit, so be it, but that's going to be my datum bore that I'm going to work to. So I've gone through and I've done my reference checks, as I said, just inside there, touching off, writing all that down and surveying it. So I've got a number of sheets here that I've gone through and surveyed. What I also do is I mark a datum point, a witness point, just on one of the faces, so I know when I'm putting things together, I know that that's that particular side there. I use that also when I'm doing all my horizontal and vertical checks as well. Just mark out where that reference point is. Makes it a little bit easier when you go back to the CAD to start playing around with things. So I've got all my bore locations, exactly where everything's at, in references to bases, and my overall heights as well. So as I did mention a little time before, on this particular one here, 71.83, 72.32, so I've got about a 0.5 millimeter that's biasing one way. I've got 1.5 mm still to come off that length there, or that width I should say. So I'm going to try and bias that a little bit to bring that ring in, so that when that housing goes on, I bore this, that housing goes on, at least those two diameters are going to be reasonably concentric. It's going to look aesthetically fine when that bore goes in, when that housing goes in. So I'm going to go back to the CAD now, and I'll have a bit of a look and see what that lay of the land is. Just one other thing I've been doing lately too, we've had a heap of instruments that I've had to make up, and I've got another little instrument called a line marking tool. This is a little instrument that I've got and developed at the moment for a company. So my little prism, that's my datum or my standard that I use, that sits in there, and got little bubbles in there and a few other little bits and pieces. So this is a little development tool. So, you know, if you've got a little workshop and you've got some ideas on little tools that you can make up for a particular company or a particular industry, a little bit of extra cash, great idea. So takes a little bit of time to muck around and get things right, and dealing with different people, but in the end, when you get it buttoned down, it's well worth it. Well worth it. So, you know, I have a little suite of these tools that I use now, and as I said, I'm developing more to go with it. So a little bit of extra cash just to help out with some of the purchases in the workshop. All right, we'll head back to the CAD and we'll get these laid out, and we'll see where we're at, and we'll come up with a machining plan. Alright guys, back again. Just completed a survey, and I've done the quick layout on the CAD just to find out where I've got to take material off, just to balance everything out nicely. So at that asterisk point, or that datum point, that datum edge that we talked about, I've got to take off 0.56 off that face. And the bottom face down here, that's going to have roughly 1.05 taken off it, but we'll just use the vernier height gauge. Once we've got that one done, we'll flip it over, use the vernier height gauge, and we'll bring that back to the width reference on the drawing. On the base, got to take off 0.58 off the base to get my bores pretty spot on. On the big face at the back here, I've got to take off 2.66, and off the ring here I've got to take off about 1.98. And that'll get everything where I need it, where I can start setting up to do my bores. So the way everything's sort of panned out, yeah, about 0.5 millimetre to take off the bottom. I only had 1 millimetre to take off that, so that's pretty right. I'm pretty happy with that. The top had 2 mil to come off it, and I've got 1.34, so you know, everything's sort of panning out roughly where I'd expect it to be. So we'll get set up. We'll knock this 0.56 off this face here, and we'll set up, and we'll do the base, and then we'll then machine everything out to length. Yeah, those welds are quite hard. I'm giving this poor old cutter a hard time. Fair bit of vibration in that. I might just take a very, very light skim pass over that and see if we can take that out. I might just clean up that little step over there first. Wasn't sure if that was the belt squealing or the birds outside. Got about 0.2 of a mil left to go. What I might do is I might just swap these, just change these tips over. I think they're getting a little bit blunted out. See if we can get a better finish on that. I've had these in for a long, long time with other jobs. I might just clean that across there first. I'll just put on some new cutting edges, and we'll reset it, and Right, I've swapped the tips over. We'll give that a lick back. I've just given that a very light skim pass and yeah, just a touch pass. What a difference a new set of tips makes. Alright, let's see how we go. So yeah, that's how a machine face should look. Beautiful. Yeah, like I said, I'd really taken those tips right to their nth degree. They're fairly expensive, these ones, so I'll try and make the most of them. Alright, we'll deburr this one, we'll flip it over, and then we'll machine that back to width as per the drawing, which I think is a 170 millimeters. So we'll do that one now, and we'll come over the other faces. Right, we'll machine up the second side face, and we'll bring that down to the total width at 170 millimeters, and then we'll start doing the bottom and the tops. Change to the tips makes such a difference, just cuts it like butter. Just do a check on that with the digital vernier and we'll see where we're at. .170 point. 170 point. 2.4. So 0.24 left to go. I'll do that in one cut. Right, let's see if we hit the 170. That's what we're aiming for. .170.01. 170.00. So that's good enough for me. Right, we'll set up and we'll do this bottom face. So we've got about half a mil to come off that, and then we'll knock the top face down. Righto, so we've got to take off 0.58 off this bottom face to get us within a bull's roar of our centre line of our bores. So we'll set that up now. Right, we'll take off a very light skim pass, and that's it. Right, we'll deburr that and we'll flip that over and machine the top and bring that back to our overall height. It's going to be 147 millimeters. And we've got a pretty good cleanup over there. Where that weld is, where I pad welded in, is where the radius of that RHS was. So, you know, we're not going to see this. It's on the bottom, and it's going to be covered up by those mounting feet that do get bolted on. So I'm happy with that. We'll flip that over and we'll machine it back to size. Right, we'll do this top face here. Just measuring it with the digital vernier or the digital calipers. I've got 148.26. So I've got 1.26 to take off the top of that, and that will be finished. So let's get it off now. See where we're at. So we're aiming for 147. Currently at 147.29. $147.28. So 0.28 to go. Got 100% cleanup on that top face. Let's just see where we ended up on that. $147.02. Yeah, I'm not going to worry about 0.02. 147.02 as well. Right. Next step, we're going to machine the two faces. And unfortunately, I should have put this angle plate further towards this way than I could have set it up beside it, but I'm not going to have enough room to run that out, so I'm going to have to break the angle setup, then machine those faces, then put the angle back in again to set up for doing our bores, which is a bit of a pain, but anyway, part of having a home machine shop. So let's get set up and we'll get that on the go. Right, I've got to take about 2.2 millimeters off this top face here. And this is going to be one of my reference faces that I want to set the bore to. This is going to be, well, the housing that's going to go in here is going to be holding that worm wheel. So I want to set the center of that worm and that worm wheel so that they're both in the same plane. So this is the datum point that I'm going to be using for setting up for those bores. We can tweak that a little bit on that housing. We can machine a little bit off the flange, or not machine quite enough off the flange and get that fine tuned, but we might as well try and aim for the best we can. Right, I'm aiming for 96.41. 96.41 is what I'm aiming for. I can take the material off the front face. So now we're at 96.58. 54, 56, 54, 55, 0. Right, 96.55. So 0.14 to come off. So I'll re-zero the digit. Turn that off. Alright, see how close we got. 96.41, 96.42. So right, so I'll just check where this face is. Once again, we'll do some comfort dimension checks. So we'll zero out our height gauge and we'll just do a touch off. 96.44, 96.44, 96.44. So that gives us 2.44 mil to come off that face, which is pretty much in line with what we measured when we did our survey work. So we'll touch off and we'll get that machining on the go. One thing I can do, that tapping block that I've got on there sits quite nicely into the T-slots. It's being 14mm wide now, roughly thereabouts, and my T-slots are 16, so that snugs down nicely. So we've got that compensating ring bolted directly down onto the table now. I must give myself a note: don't wear a nylon jumper when you're machining, because they get stuck everywhere and then it burns into it. Yuck. My wife's going to be very happy with that. 94.43. 94.43. We'll work on 94.43. So 0.43 of a mil. Alright guys, you'll have to excuse me, I've got a little bit of a head cold at the moment. It's been absolutely freezing at work. We're going to do a bit of a stop and prop here at the moment. I've got the CAD set up because there's a couple of, or a particular change that I'm going to make. Now, we've completed the machining of this housing all over, and we're about to start the ball work to be able to fit these bearings into place, and ultimately the worm shaft. One of the things I've been waiting on is some of those proprietary items, those bearings. So I've actually received all the bearings and all the seals, because there's one particular dimension that I'm not sure of, and unfortunately the catalogues don't tend to show this type of stuff on bearings, and I wish they would, because it would save an awful lot of hassle. And that is that inner diameter of the cup, so that you know what the envelope space is you've got to work with to get things through. Now, in this particular case, my worm is not going to pass that cup. So there's a couple of things we're going to do. Ideally, it would have been nicer to put a larger bearing in here, but as you can see, I'm not going to fit anything much larger in than what I've got. I've really stretched the envelope space completely, with the fasteners, with the gaps I've got. Everything there is just really, really tight, and I couldn't really go to a bigger bearing. It would have been nice, then I would have been able to pass this this worm shaft through. So we've had to compromise, and that's why I've gone with the smaller bearing diameters. But I was hoping that we might have been able to pass that worm through, but we can't. We're shy about 2 millimeters. So we need to design something in there that makes it easy for us to remove that cup with the shaft. Now, if I was just going to rely on the worm faces to try and push that out, I'm going to hit here, I'm going to get here, it's all going to be cockeyed, and it's going to get skewy, and it's going to jam inside that housing, so you're not going to have a hope of trying to get that out. So we need to put something else onto that element, that shaft, that's going to aid us, and I've put a thrust washer onto that shaft. So we're going to shrink that into place, the idea being when we go to punch that through, that face is going to kiss up, and that's going to allow us to take that cup out with the entire assembly. I normally like to try and shrink these cups into place, ideally. On small bearings, on larger bearings that's a different story. There's different practices that we use for large bearings when we're fitting cups into housings. Sometimes you'll want them to rotate in the housing, and traditionally you'll try and look at 1 revolution per 12 months. That's ideal, so you can even that wear throw out. Sometimes you don't want them to move, and you can actually dowel them in place, or the oiler, there'll be a dowel oiler hole, so you're actually feeding oil down through that hollow dowel into the bearing. There's different ways that you can restrict the movement on those cups. And worst case scenarios is if you've ever seen a cup, actually a big cup, rotate in a large gearbox, it does tend to make a bit of a mess, and you can actually see a huge wear pattern. And the more that wear pattern gets, the more issues you have with your alignments of a lot of those elements. But for these little fellas, I like to shrink the cups in place. So this one here I'm going to shrink in. This one here that I want to move out, it's going to be a transition fit. So it's just going to be a very, very light push fit into place, so that we can punch that out quite comfortably. So what does that mean? So I've changed the diameter in here. I've actually increased that out by another 1.5 mm. I've made sure that I've got a good land still there that I'm going to be able to butt up against, and the idea is that that thrust washer will then sit inside. Lubrication, the lubrication is going to be running up about 1/3 of that worm in practice, so that lubrication is going to be able to get through. I suspect that when this is actually rotating, it's going to act more like a labyrinth and prevent oil coming in. But if we've got oil in there to start with, we should be fine. So that's just a little update on what we're going to do. So as I said, I was waiting until I got these bearings in hand to see how that was going to play out for me. So that's how we're going to go about it. Design is often about compromise, and you juggle a lot of balls to come up with the best fit for a problem. And sometimes other areas need to sacrifice, but you'll always try and minimise those sacrifices you've got to make in your design. Alright, so I'll re-detail that housing and with my new dimension sets on that detail sheet, and we'll set this up and we'll make a start, and we'll go through the methodology of how we're going to go about boring these housings in line. Alright, see you soon. Alright guys, before we go back out in the workshop, I thought I'd just go through some of the proprietary items that I've got off eBay, and this stuff's as cheap as chips. It's my old SKF bearing catalogue. It has been through the wars, and I've had this for many years, and had many arguments over it with bearing engineers in limits, fits and tolerances, bearing lives. Alright, so we've got all our bearings for the job. Always get very nervous when you get a bearing that arrives that isn't in its plastic packaging. So you know, for this particular job it's not an issue, but yeah, if it was a critical job, you'd be a little bit concerned. We've got our lock nuts, we've got our seals. There was one seal I did buy from my local bearing supplier because I wanted a seal that only had a single lip on it for this larger one of the crank disc. I'll go through why that was the case. Lock washers, they're the that's the worm and worm mill I got off eBay. I think I paid about $60 for that delivered, so that's what we're going to be using. Obviously I'd like that to be an alley bronze or some sort of a bronze rather than the steel, but we're going to use a high pressure bearing, high pressure gear oil in this, which is hopefully going to afford us some protection. It's not under a huge load at all, so we'll see how that pans out anyway. I thought I'd just sort of show you the bits and pieces we've got. I've got my timing pulley and my timing pulley belts in there as well, so got that all ready to go. I've got a couple of various sizes there so I can play around with the ratios, but as I mentioned before, I'm going to put a 3-phase motor on this with a little VFD so I can sort of tune that speed up. Alright, so that's sort of everything we've got purchased, and I don't think there's much more else we need to purchase for this, other than a few fasteners. But other than that, I think we've got everything we need to get moving. Alright guys, we'll see you back out in the workshop.